So question number 4 is actually one of my favorite questions, and I've seen this on numerous exams throughout the past 6 semesters I've been teaching this. And it says that a block of mass 10 kilograms sits on an inclined plane. So the first thing I do here is I'm going to draw an inclined plane, make sure you have your right angle, with a mass of 10 kilograms. The coefficient of static friction between the block and the surface is 0.75. So it's telling us that mu s is equal to 0.75. At what angle in degrees must the block be raised before it begins to slide? So we're looking for this angle here in order for the block to begin to slide. So anytime I do a question like this, I always think about a chart and what different forces we're going to use for the problem. So I always make an x and y chart to solve any of these force problems. So we know we have a weight force, we know we have a normal force, we know we have a friction force, and that's actually it for all of this, and of course we have a net force. Sometimes, however, you might have a pulling force that you might add into here. So this chart is a really good way to organize all of your thoughts, and we'll go ahead and show each direction it's in. So for the y direction, we'll start out with the simple normal force. The normal force is always directed in the y direction. So this is the normal force. If you want to visualize this question a little bit better, you can think of the incline that the block is on as the x direction, and we can divide it down with a 90-degree angle as the y direction. So here the normal force is only directed in the y direction. So we're going to go ahead and put a 0 for a placeholder here and call this Fn. However, the weight is directed straight down as always. But normally the weight is only in the y direction. However, in this case, there's weight in both the x and the y direction. So in order to figure out how much weight is in the x and y direction, you kind of draw a right triangle out here to say, okay, my weight is still directed in this region, but now we have an x direction and a y direction. The x direction here is parallel to the slope, and the y direction is just a continuation of the normal force and the coordinate that you drew. Because of the law of opposite interior angles, this angle theta is also equal to this angle theta on the triangle. So if we want to find the weight forces for our x direction, we take opposite over hypotenuse, so it's negative mg sine of theta. For the y direction, it's negative mg cosine theta. You might be asking why I put the negatives here. Well, the negative for the x direction is still going to the left. So just like vectors we learned, down and left are negative, while up and right are positive. So the weight is being directed to the left, that's why we have the negative sign here, and the weight is also being directed downwards towards Earth, which is why we have a negative here. Finally, we know that the friction force is always opposing the motion. So friction is equal to mu s times Fn for static friction. If you had kinetic friction, it would be mu k times Fn, and we'll just put it as a placeholder here. We know that normal force always equals mass times acceleration, but the block is not accelerating. So acceleration is 0, so our net force ends up becoming 0 as a whole. So if we look at this, we could say, okay, Fn minus mg cosine theta equals 0. Just think of this like a giant addition problem. So if we rearrange, we could say Fn equals mg cosine theta. So on this part, we could say mu s times Fn minus mg sine theta equals 0. Or we could just rearrange it and say mu s times the normal force is equal to mg sine theta. Now we have two equations, and we have the theta variable, the angle we're trying to solve for. And we have what the normal force equals. So the easiest thing we can do is just use a system of equations and substitute mg cosine theta in for the normal force. So mu s times mg cosine theta equals mg sine theta. So in this question they give you the mass of the block, which is 10 kilograms. But in some questions they might not give you the mass of the block. Don't be confused by this, because mass and gravity end up canceling on both sides of the equation. So you could go ahead and plug 10 kilograms in when you multiply on each side, but it's not necessary to. We know that the relationship between sine and cosine is equal to tangent. So if we rearrange this and we want to solve for theta, theta is actually equal to the inverse tangent of mu s, which we said before was 0.75. So the angle that the block is at ends up being 37 degrees. And that is also answer choice number 1. So inverse tangent of 0.75 is 37 degrees.